we define the graph of a function is a set. So let's give the most general definition of a set. So I will call my set name as F, and this set has domain and codomain, or range. So this is domain. In Korean, it's called 정의역, and R is the range, and that's called 시역. And we are in the space of multivariable function. Our D and R is not an interval. If it's both interval, then we are talking about the single variable function. Since we are talking about the multivariable function, this D lies in some n-dimensional space, and this R lies in some r-dimensional space. So what is n-dimensional space? It's a set of n tuples, n pair of numbers. So say x1 to xn, where xi are real numbers, and Rm are the same. It's a m tuple of numbers. So whenever we have a point inside of this domain D, the subset of Rn, we can put that point into the function f and getting another point which lies in m-dimensional space. So in that case, the graph of function is the set called g of f, and this is nothing but the pair of n x coordinates and m y coordinates. So for example, when I put f as a multivariable function, each m coordinates in the range should be the function in terms of x1 to xn. So I'm going to write that as x1, xn as independent variable, and then so first variable in m-dimensional space as y1, and this y1 is again becomes a multivariable function which depends on x1 to xn. And we have total m number of variable in our range, so it goes up to ym. And that tuple, so how many numbers we have? We have n independent variable and m dependent variable. So you see this y1 to ym is a variable that depends on the value of independent variable x1 to xn. Okay, these are numbers. Okay, so we have n plus m number of real numbers, and we only are able to move this x1 to xn freely. These y1 to ym are fully determined by these n values, and the condition that this x1 to xn satisfy is that this point should lie inside of the domain D. So this is our definition of a graph. So let me mention again, this y1 to ym is a symbol for common symbol for dependent variable. So we usually write this function f as the following. So we input the x1 to xn, we get the value y1 to ym. And you see each y1 to ym is again becomes a multivariable function because the value of this yi is the real number, and the real number is dependent on this y1 to yn. So each yi is again a multivariable function. Okay. Here I is from 1 to m. Okay. So whenever you have multivariable function, you can split your multivariable function into each coordinate functions, and each coordinate function is nothing but a function from some subset of Rn to the real number. So once you understand how does this kind of function looks like, or how to graph the function, how to understand this kind of function, then you can fully understand the general multivariable function. Now, last time we talked about how to draw the graph of function of the type z equals to f of x, y. All right. So for example, we had x squared plus 2y squared. And I finished off by saying that if you're just plotting the points, then in between, in the area, there could be an area that you don't know what's going on inside of the graph. So we will talk about that more, how to handle that situation. Before we move on, do you have any questions? 정의에 질문 있으세요? 이해 안 되거나? Okay, let's begin with what we left. We have main function, and we put everything in the main function. And I think, so let's see. The result was like this. So we don't know what's going on inside. So what was the problem? Because the problem is because we plotted the points. There are lots of points accumulated in some area, and we don't know really the shape. We cannot see the actual shape of this graph. So what other method that we can use to graph the function instead of plotting the points? 그래프를 그릴 때 점을 찍으면 이제 저 점이 이제 막 모여 있는 곳에서는 그림이 어떻게 생겼는지 모르잖아요. 그럼 점 찍는 거 대신에 어떻게 하면 되겠어요? That's a good idea. You can use a different color, like a gradation. And also, you think you should use the transparency of the. So here I used I didn't put any transparency of the point. Can we think of other method? That's a good way. You can try that one in your own code. Let me show you some picture how other program usually draws the graph of a function. So let me go to images here. Well, that's a good example here. So how does this graph look like? This is a graph of some two variable function. How does it draws?
Have a line that to know.
Right. So we have a mesh line on the surface to visualize the shape of the surface. So instead of putting the points, let's take a line that connects each point in mesh grid between points which are located in the mesh grid. Okay, so let's try to do this. So I define this function, and let's briefly review again. So I started my main function by defining my new plot. So plot is the package that the GNOME is included in the gnome.org, and I just installed this package, plot package, using the installation command. And P is created by this new method, a new function in the plot package. And so this one is drawing x-axis, y-axis. So these 3 or 5 lines are for drawing y-axis, and this is for drawing x-axis. Sorry, z-axis, right? Z-axis. And the last one is for drawing x-axis. Okay, so and I did hide axis, which means that I'm hiding the xy plane, xy axis in the 2-dimensional figure, because whatever I'm drawing here is drawing into the 2-dimensional space, 2-dimensional canvas, and I'm deleting this xy axis in 2-dimensional canvas. And I define this function, two-variable function, and n is the number of subdivisions that I divided this x interval and y interval. And before we just plotted the point, I'm going to add a line. So I'm going to introduce how to define array in the programming Go. For now, the array that I have to create is the plotter xy type. So plotter xy type is the array of xy types. Let me go to the documentation again. GNOME plotter. Is it plotter? Yes, plotter xy. So if you go to here, let's see, the type says XYS is a type which is defined to be array of XY. This bracket means that it's array, and it's array of XY type. And there is a link. When I click it, it goes to the definition of type XY. And now type XY is the struct consists of 2 fields called X and Y, which is of type float. So float means it's a real number type. So therefore, if I want to draw a line that connects the points, then I have to make an array of XY types starting from one point and ends at the end point. So for example, I have domain of the function x squared plus y squared as 0, 2 times 0, 2. And if I plot that domain inside of this 2-dimensional figure, I'm going to divide that into n subdivision, and then try to make a grid point. Okay. And starting from these line, and pick a point that connects this grid point, and tries to corresponds these points to the 3-dimensional points, which lies inside of the graph of function, and then connects the points inside of the 3-dimensional space, and then draw it onto the 2-dimensional canvas. So pick these points. So we have, this is x-axis and this is y-axis. We have x-axis here and y-axis here. So these points corresponds to these points. But this is not the point that I wanted to draw in the 3-dimensional. I want to draw somehow these points on 3-dimension, and then connects that on with the lines, line segments, short line segments. And in fact, I don't need to draw the point itself. I just need to draw the line. So we already had we already we already know how to draw the line because we already did draw 3 lines representing the axis. So I'm going to use the same function, new line, to draw that. So let's go back to here. We have points. Already defined the points, so I don't need a column here. And I want to make an array of XY type. So plotter XYs. So number of elements in that array should be n plus 1 because I subdivided into n subdivision. That means I have n plus 1 points inside this line. So this is point, and let's see. So I'm going to set I as an index for x-axis and j as index for y-axis. For example, this is index 0, 0, and this is index for 1, 0, and this is indexed by 2, 0, and so on. So at the end, this will be n, 0. Okay? This is not the coordinate. This is the index of coordinates. And then let's say, let's see. I want to add. Let's delete all of this for now. I want to add at the jth position of this point, which is the array of plotter xy, define that as a plotter xy type, not xys, because xy's s is the array of xy's. At the jth element must be the xy type. And this xy is, so first x coordinate should be, since it's subdivided from 0 to 2, 2 times float type of I divided by float of n, right? And y is 2 times float type divided by float n. So whenever you define a field, you have to put a comma after definition. And definition is a little bit different when you define a field value inside of the type, because instead of putting an equal sign, you have to put a colon sign here. That's that's the grammar of the Go. And okay, that's it. So once you run this iteration, you have n plus 1. You have an array containing n plus 1 elements inside a PTS variable here. And the next step is to define a line by plotter, new line, using these points. And then add that line into your plot. Okay? So what does these do? So basically, I'm iterating this, making point and plotting lines connecting points for n plus 1 times by changing I from 0 to the n. So when I is 0, I'm actually taking j move from 0 to n, which means that I'm moving my y coordinates. So I'm taking these array of points and then plotting the line connecting these points. And then I move my I to 1, and then I'm changing my j from 0 to n. So I'm taking these array of points, and so on. So basically, if I done this for once, then I'm getting these kind of picture, not this one, these kind of pictures. We have these picture, so on. Let's check. let's check by drawing this picture. So let's save this. And okay, we have some error message here. So let's see. Okay, so we have a function f. Oh, I forgot to actually making points. Sorry. So right. Okay. So, I'm sorry about this. So we have. This is not the way we did in the previous. So before we do this, let's see. Okay. This x and y are not actual values, so it's a coordinate inside of the 2D canvas. So let's redefine my x and y value here. Okay. I don't need a comma in the actual Go command. And I'm going to define my value, z. And then my xy coordinate in the canvas is different because I have to use the vector notation. So for, what was the formula for x? So for the x part, let me go back to whatever it changed. So let me go review briefly what we have done here. So for this vector, we choose it to be square root of 2 minus, and then this vector, we choose it to be 1 here, 1 comma 0, and this vector is chosen to be 0 comma 1, right? So whenever we want to draw the points on x, y, z coordinates, then yes. Oh, sorry. So we have x, y, z is equals to x 0, 0 plus y 0, 1, 0 and z 0, 0, 1. But then I have to translate into two-dimensional canvas picture. So this 1, 0, 0 becomes this two-dimensional vector minus 1 over square root of 2 minus 1 over square root of 2. And then this one becomes 1, 0, and this one becomes 0, 1. And all the coefficients are the same. And this becomes minus x over square root of 2 plus y. And this becomes minus x over square root of 2 plus z. So this is my x coordinate, and this is my y coordinate inside of the two-dimensional canvas. Okay, so that's the xy coordinate that I have to put here. So here we have x times minus x divided by square root of 2 and plus y, and y coordinate is minus x as square root of 2 plus z. Okay, and let's save, and let's see what's the problem here. No problem. Okay, so let's go to terminal, and let me move this, if I can. Let me move this panel here. Okay, so yeah, that's better. So I'm going to run this code by taking go run main.go. Okay. So since we saved that in 400 times 400 pixel PNG file, okay, this is how it looks like. Well, it's It's better than plotting the points, but it's too many lines here. So let me make it smaller. So let's use just 10 or 11 elements in the array. So let's save this again and go run main.go. Okay, it's not finished yet. Okay, so this is how it looks like. That's what we expected. We only changed the y indexes for each x indices. So we have one side lines here. We didn't put another lines here, right? So we have to do this a similar thing again using switching the x and y indices. So let's copy and paste these lines. So, and then let's put here. So instead of starting from I'm trying to start from j, and I will move my I here. Then x, y's are same, and going to put a line here. So and then saved again, and then run again. So you see, I didn't change anything but the indexes x and y. Okay, so something is wrong here. So it seems like x, y, j. Let's see what the problem is. Oh, I changed this to I, right? So because I is now moving from 0 to n. So let's rerun. Go run main.go. Okay, and now this is our figure. So you're looking at the first quadrant of this over thing, the parabola surface. So if you want to see actual parabola, then you have to draw this in the domain containing the 4 quadrant. So we only put the first quadrant, so that's the figure. But that's actually better than putting the points. If you want to see a better figure, then you can increase the number of subdivisions. So for example, let's say 100 is too much, so maybe 20 might give a better picture. So go run main.go. Let's wait. So a little bit looks like it's actually a curved surface, right? But in fact, if you look closely by zooming in each lines, then each line are actually the straight lines. It only appears to be a curved surface because we are looking at far distance. Okay. Any questions? Any questions?
I have a question about the vector right here.
Mm-hmm.
So you selected each coordinate, the coordinates of each axis.
Mm-hmm. Mm-hmm.
And I didn't understand why you choose those numbers.
Are these numbers?
Right.
on the right-hand side here, these numbers? Okay, so good questions. So question is how I choose these numbers in vector, two-dimensional vectors. So since it's a three-dimensional figure, we have to put it in two-dimensional canvas. So this is like two-dimensional canvas, and I have to think these line as two-dimensional line. So in the previous lecture, we had this line as a horizontal line whose lengths are 1, and this is vertical line whose lengths are 1. So I have to put this line as the same length and also 45-degree downward line. So that's why I had to put this line as minus 1 over square root of 2, minus 1 over square root of 2, because in Pythagorean we have 1, 1, then, I'm sorry. So if this is our 1, then you should have other sides equal to 1 over square root of 2. And it's left and right, so I have to put the minus signs here. And then it gives a picture that we can imagine as if it's a three-dimensional axis. And then I have to convert that each x and y and z vectors, the unit vector, into these two-dimensional vectors to show this picture as if it's a three-dimensional picture. Okay. Any other questions? Question? No? So I want to emphasize why I'm doing Go instead of using MATLAB, because MATLAB doesn't bother think about these situations. You can just put in your equation or formula, and then using few commands, you get the graph of function. Why am I bothering using Go? Because Go makes you think systematically to solve your problem. So at this moment, this code looks nice because it's long and complicated, but it's not really good when you explain this code to others. Other people cannot understand this code efficiently because they have to read this code line by line what you're doing, and then there's no comment. There's not many comments. So think about what we are doing here by commenting everything we did so far. And let's start off from beginning. So what I really want to do is define a function and graph the function. Okay? Let's put that in two sentences. So I want to define a function f as a multivariable function. So I'm going to add xy, float 64, and float 64 as a function. And the return value is x times x plus 2 times y times y. And that's it. That's my function. And I want to graph it. Somehow, I want to graph this function. So let's say graph this function. And whenever you graph some function, you need to specify the domain of the area, the domain where you're going to graph the function. So in this case, we have two-dimensional, two-variable function. You have to put the lower limit and upper limit for x-axis and y-axis. So you should have 4 values representing the domain, the boxed domain. That should be it. This is the not the two line, but the simple way to think about what you're going to do. Now we have a red line below the graph because we didn't define what graph is. So let's define our function graph. The function graph takes the 5 arguments. First argument is the function type. Function type where we have float and float. It takes the 2 values of float type and then it returns the float 64 as an output. And then the rest of 4 inputs are float type values. So we have float, float, float. It's not really a good way to do this, but okay, so float 64. So that's how you, that's how the first argument is defined, okay? And, right. So that should be in the parentheses, okay? How many floats we need? 1, 2, or one value of float, right? Right, that's it, right? Mm-hmm. And let's give a name for these inputs. So it's the local variable, but I will going to use the same name for f. And we have x0 as the first argument, x1 for second argument, meaning that this is the lower limit and upper limit for the x-axis, and lower limit and upper limit for y-axis. And that's the argument of the graph. And what does graph do? It should graph a function and have to output that function, a graph, as the file. So from this point, we have to copy paste everything that we have done in previous line. So we are going to just paste that here. So we're going to add, make a new plot, and then drawing the x-axis and y-axis, z-axis. But you have to be careful because in before, when we put everything in main, we knew that our domain is 0 to 2, but here we input specific domain. So I can change 0 to 0 to whatever I want, so you have to change your coordinate accordingly. So let's put 1 here instead of 2, because I just want to graph the shape of x-axis, not to make it longer until it reaches to the side of this area. Make everything as unit vector here. And also, I don't need to define function here because it's already defined as an input. So f is already defined. So let's delete this. And n is the number of subdivision that should be defined inside a function. I don't have to, you shouldn't remove this. But now, let's see. The x coordinates should be always the same for for the same I. So I have to subdivide that from x0, the lower limit of x-axis, to the upper limit of x-axis, which is x1. So it should start from x0, and then I have to subdivide my interval from 0 to x0 to x1 by n, and then the i's coordinate is the multiple of these numbers. So we have this as x value, and how about y? So y, for the same, it's y0 plus y1 minus y0, and times plus j. And everything's the same thing. You just draw the lines. And here we have same j for same y for same j. So do the same thing. So y0 plus y1 minus y0. And x is x0 plus x1 minus x0 times I. And everything is same. So it ends with the save, and then doesn't return anything. You're just getting a PNG file at the end. And let's save it and then see what's, oh, there's nothing wrong here. This is not a error message. Okay. Let's try to run this code. So go run main.go. Since it should have the same figure, so let's change a little bit. Instead of putting x squared plus 2y squared, let's put x plus 2y squared. And then save and run. And the result has to be different than the previous figure. It works fine, right? So in this way, whenever people want to read your work, they have to just read this main code. So by looking at this code, you define the function and you graph the function. Simple. So they don't need to understand how you graph the function because they can see the result. If it doesn't work, then you have to go through how you did wrong in your graph function, but you don't have to show everything in detail when you explain your work. This is how you have to think when you break down your problem in your project. So make it as simple as possible in a few terms, and then go deeply into each of the terms. I will tell you how to make it more simple than this one by using the type. So the type is common way to write a code in any programming language. There are another name for the type in Go. Maybe in the programming language C, you can call it a class, or C++, you can call it a class, or there are other names for other programming language, but Go likes use the type. So I'm going to name my type as MVF. So MVF stands for multivariable function. And this multivariable function is a type of function, is taking a float, array of float, and outputs array of float. So this is a function, and you make this kind of function as the type called MVF. Okay? So I'm going to define my function f as x and here y, and let's see, float 64. I'm going to define in this way. Is anything wrong here? Oh, sorry, I shouldn't put y here. So let's see. Okay, so that's it. So I'm going to define my function as the type. I didn't put MVF name here, but I used the same syntax when I defined my MVF type. So the input variable is of the array type of float values, and I gave that name as x, and the output should also be the array of float values. I don't have to put a name for this because that's going to be just the output. And the return value is that I'm taking the first element of this x array and then plus the square of that second value, which is indexed by 1, and then return it as the array type. So this is how you define array in your Go. So you put a bracket here and then float, and you start from start your elements inside of this parenthesis. Since we have only one variable to output, so we have one variable. But if you have more, then you can put more here. Like for for example, if you want to put 2 zeros afterwards, then you can just put it here. So then here we have used 2 to 3 function. So you have 2 inputs and 3 outputs. But really, you don't need this second and third variable to output. So this is 2 to 1 function, just like we defined in here. And that is exactly the same type of MVF type. So you can use this function f as if it's the same type of MVF function, MVF type. And then, why do I make this type of function as a new type MVF? Because I can make a method that defined inside of this type. So let's say f is an MVF type, and then I want to make a graph function. So I didn't put anything in this content of the function, but what I'm going to do is, since I defined my function f as the same type of MVF, I can just call this function graph by taking dot after this name of MVF type. So f dot graph of, now the graph, whenever you graph something, you need to specify your x range and y range. So these 4 numbers are necessary, but still we don't know whether you need 4 or 6 because you don't know how many input arguments are there. So I'm going to make it as an array of floats. Okay. So graph function takes array of floats, and that's going to be the limit. So I'm going to call that argument name as lim. And there's no output because the output will be just saving the PNG file. And that's it. Let me change it to MVF type here. So I changed my function type as MVF type, as I defined my MVF is same as this function type. And there's nothing wrong here, right? There's no error message. So what has to go inside of this graph function? It should be the same thing I just did in the graph function, without any specifying the type that this graph function is included in. So just save, copy, paste everything. Oh, sure. Okay, let me just go again. Just copy, or just paste here. Okay, the plot new and everything, x, y, z axis fine, and the number of subdivisions are fixed as 20. And now let's change a little bit of syntax here. So the index always runs from 0 to n, but the starting point is now not x0, but this is the first value of the lim, because I took lim as my array of x range and y range. Okay, so lim 0 is the lower limit of x range. So I'm going to change it to lim 0, and lim 1 is the upper limit of x range, and this is lim 0. And everything's same thing as before. So we have y0 as lim 2, and y1 is the lim 3. So lim is indexed from 0 to 3, so 3 is the last value, lim 2 here. Oh, sorry, so I forgot this parenthesis. And do the same thing for the second part. We have lim 0, 1, 2, lim 2, and we have lim 3 minus lim 2. And we have lim 0, which is a lower limit of x range, and lim 1 minus lim 0. Okay. So let's see. Okay, so again, so this function is now called a method of the type MBF, because it called by method f. Okay, so method f calls its function graph. So I have to use this type MBF and as the function inside of this graph. So we have an error message here which says that I cannot evaluate this way because this f is defined as the function type takes the array of floats and outputs the array of floats. So I have to make this input as array of floats. Floats, 64, x and y. And now z also becomes array of floats, but it only has one element. So I have to take the first one, which is z0. And same thing for the second part, array of float 64, and I have to use the first value of the output. We still have some error message which says that I don't need this, right? And f.graph. What's the problem? Let's see. Is undefined. What? Didn't I put what's wrong? Okay, so I did put MBF in before, so I have to put it again here, right? Okay, so there's no problem here. Everything should work. So let's save and try to look at what's going on. I have to change a little bit because it will show the same picture. So let's say now I want to make it a little bit different than before. Let's say I want to take x squared plus 2y instead of y squared. Then the formula should be like this, right? So let's go run main.go and see how it looked like. So this was previous picture, and now the new picture looks like this. So we have a flat line for x direction, and when y changes, it's curved a little bit, right? Now, I'm making this code more readable, making more and more readable to others. However, this main.go contains too much information. I just want to say I want to define a function and draw the function. And that's all we need in the main.go file. So I will going to delete everything here. I want to delete everything here. I just have this main function inside of main.go. So where should the rest of the part go? I have to make it as a module. So module is it's like a package in Python, if you know Python. In order to make a module, I have to make a subdirectory. So the module name is going to be mbf. And inside of subdirectory, let's make a new file called mbf.go. So in here, I'm going to call this package name mbf. It should be the same name as a directory name that contains this file. And in the main, we had these lines. And I'm going to paste that in this here. So let's uncomment this. So the reason why you have red lines here is because import is not went through all the way. So now it's gone because Visual Studio Code auto imports all the packages that you used in the code. So we did. And there's no error message here. Nothing wrong. It only defines the type and it defines the method that define the inside of this type. MVF. Now, what we should do inside of main is that we have to import our subdirectory or submodule MVF. So multivariable is the name of this project. So whenever you, if you remember correctly, then whenever I made this folder, I named this module or initialized this module name multivariable. You can rename it by changing these contents here, but I will stick onto this multivariable name. So I'm going to, where is it gone? So I'm going to import multivariable / MVF. So I'm going to import my submodule inside of my project multivariable. So inside here, I'm going to use MVF.MVF. So what does this mean? So I'm calling MVF's module, which is imported in here, and then define my function as MVF with capital M. So capital MVF with capital M is the name of type, and MVF with smaller m is the name of module. So I'm using MVF type inside of MVF module. Let's save. Multivariable. Did I messed up with the name? Variable. Okay. I forgot A here. Maybe I should make go module go mod. Okay, so that's the problem solved. Okay, nothing wrong. There's no error message. So main.go only contains the content, how I define my function, and what I'm going to do with my function, graph it. And everything in detail is contained in the submodule MVF inside my project. So people don't need to see what I'm doing inside my method graph. It's a very nice way to handle the problem. So our goal is to graph the function, then we did it. And if you are working together with other people, you can just set your main scheme and then try give the task to other people's, which is split it into smaller pieces or smaller modules, and then try to write a code in each module for each person. So let's see whether it works fine. Let's change it to x plus 2y. Now I deleted all the square signs here. And then save. Maybe I should save everything here. Save, auto-save everything. Auto-save. And go run main.go. Let's look at PNG file. Now you have a flat plane, right, in three-dimensional space. I didn't change my domain yet. Let's see how it goes when I change my intervals. So instead of 0, 2, 0, 2, let's say I want to put -2 to 2 and -2 to 2. That means I'm using all the 4 quadrants. And save and go run main.go. You should probably see the similar figure, but now it runs for 4 quadrants. So you see the axis, which only gives you the line from 0 to 1, 0 and 0, 1 is getting smaller because you have a larger z or x values. Maybe not x value. X and y values run from 0 to 2, but z value getting bigger. So you have this figure. And well, let's see what's going on when I change it to our original function, the square function, x square and y square. You should see the parabola right? So this is how you graph the function. So entire parabola is now showing correctly. Okay, let me tell you how. So this is your assignment. Actually, this was your assignment, when I put in here. So we had in the programming tab defining a multivariable function, and task is to define a module mbf, and file should be mbf.go. Okay, so let's see. I should have a small changes here. So methods should start from the capital letter G, and I didn't make a new function here. Let's try to do this. So, okay, so whenever you have a package which contains a type, then it's customary to make a function that creates that type. So I can make function u mbf, which well, it doesn't really make sense because the mbf is already defined as a function. So if I really need to do, I have to just just copy paste the same thing here. So I'm taking a function defined as a function takes the array of floats and outputs the array of floats to mbf by returning that function changing to type mbf. That's all. So if I want to use the new mbf function which creates a mbf type, then I have to do this mbf new mbf function and so on. That's it. So it doesn't do anything new because I could just use this mbf type conversion from this function. Why we need this? The reason why we need this is sometimes you don't want to make this type public. So putting capital letter of your name of type means that you can access this type outside of this submodule. So that's why we just could have used this mbf dot large mbf. So if you used your name of type as starting from smaller letter here, I have to change everything in small mbf here. Maybe let's try this. mbf, mbf, and mbf. So everything is gone here. So if I do this, now the red line doesn't disappear because it says, well, there's no import here. So import multivariable mbf. Okay. It takes a little bit of time here. So, all right. Now we have a red line here, the error message, which says that mbf not exported by package, which means that you cannot use your mbf type inside of the mbf package outside of this package mbf. Inside of mbf package, you can freely use the type, but because you put a smaller case letter in front of the name, you cannot export that outside of the package. Sometimes you need to define your type hidden outside of the package because you don't want other people to access your type field of the type, or for other reasons. if you have, you should use this the hidden type inside your package. But then, how do you make a new type? Then you have to use this function, function which is public, because I use the capital letter in front of the name. Then I can make a new method here, create a new type here by taking new, new MVF here. So there's no error message now. Let's see, it works nicely for the last time. So, okay, it draws the nice graph again. So this is assignment. This was the assignment. Now let's see how I'm going to put my result in assignment as if I'm a student. So I said that you have to go to the Replit. Okay, so it's auto logged in here. So let's see. I have to create a Go module. Not Go module, but it's a Go Replit. So I'm going to name it like assignment 2, multivariable function. Assignment 2. And if you're not paying anything, you have to make it always public, but no one will mess up with your Replit things. And so here's my new Replit site. You have to basically embed this site. So copy paste, and I'm not going to do this in the template page. Let's go to my dummy page. Where's my dummy page? Where's my dummy page? It disappeared, so let's do it in template. So here, considering this is your page, and you copy it, paste, and not this one. So here we should have programming, define a multivariable function. And let's see, now result is, so slash REPL gives you the pop-up which you can embed your Replit page. So click and copy paste the Replit page link and embed a Replit. And you wait a little bit, and you see the same page that you're seeing from the Replit site. So same thing appears here. So now what you have to do is copy paste every files and contents to the Replit here. Okay. For example, for the main, for here, for the main.go. Here, delete. Copy, paste. And then, so main.go itself doesn't do anything because you need a package. So you have to create your folder called MVF, and then inside the folder you have to add file, which is mvf.go, and you have to copy paste everything here. Copy, paste, okay. And inside of Go module, so that automatically makes your name a module as main, but let's make it a same name I did, multivariable. You can make it a different name. So I'm using this name only because I don't want to change my content of file main.go. And go test your code, go run main.go. And server is a little bit slow. It's finding the necessary module because we use the plot module and plotter module in mvf.go, so it automatically detects the unimported packages and installing it. Okay, so you have to wait a little bit. Meanwhile, let's visit our Notion page. So in the Notion page, it shows the same thing here. It's synchronized. So in the file contents, we have a file that I created and edited here. So I can see, and you can also see the thing that you have defined. And let's check whether it's done. It's still going on. Okay, it's done. Let's rerun this. Because after finishing running this graph, we should have a PNG file created in this main directory. So let's see why it doesn't compile. Let's see what happens when you do go build. So I heard that it uses one CPU core for free version. If you pay some extra, you can use 4-core CPU. That's why it's so slow, because I'm using free version. So it's done. So when you're done, you have new file called Multivariable, which is the same name as I defined my module, the main module, and it's a executable file. So let's say okay, so executed multivariable. Then see there is a new file created, test.png. So here's the picture. Okay. So if go run doesn't work, go run main.go creates a temporary executable file. So sometimes it doesn't work. So then try go build and then run the executable file created after. All right, so I already embedded here. So that's all you need to do to finish your assignment. I don't want to leave this embedding here, because in that case, you can just simply copy paste what I just wrote in this content and then to your Replit page. But for now, I will leave this as for your information and for your future reference. But from now on, I'm not going to give you the answer by embedding my Replit page. All right. So this finished our first task. Let's draw the graph of a function. So here becomes a new questions. So far, we only draw the two-variable function. How about other type of functions? For example, we had a function of this figure. So we had ct equals to xt, yt, and zt, where t runs from a to b, right? How do we draw the graph of this type of function? Remember we had discussed how this graph looks like. In principle, it should lie inside a four-dimensional space, right? But we don't need to draw in four dimensions because we can only look, if you just want to see the trajectory inside a projection of three-dimensional space, you can draw that in three-dimensional space. So let's say this is x-axis, y-axis, and z-axis. Suppose that it starts from the origin and then moves in this trajectory. You can only take at each point of time t what's the x and y, z coordinates of this function. So let's say this is t0, c t1, and c t2. So we had for example, this is ct0, this is 1 and 2 and 3. So it goes on until it start from A to B. So A should be t0 and B should be tn. So if you subdivide it into n pieces, then it should have n plus 1 subdivisions and subdivided point. And then all you need to do is connect these points by straight lines. Okay. So let's try to do that. Here we have. So far, what we have done in this mbf.go is to graph 2-to-1 function, right? So I'm going to rename this 2-to-1. So because it only works for 2-to-1 function. Whenever a function takes xy and then spits out the z, then it works. I cannot make it work for this type of function. I will define a new function f mbf and graph of 1 to 3. So 1 to 3 means that we have 1 independent and 3 dependent. And okay, so it's similar. Let's see, I used a smaller MBF, so let's copy paste first few lines. We still need x and y z axis, and we still need the number of subdivisions. So let's copy paste the first few lines here, and then for the rest of the parts. Let's try to iterate that. So in the plotting the two-variable function, we had to draw a grid line. Here we don't need a grid line. We only need one-dimensional line. So we only need to iterate once. So I from 0 to n and I plus plus. Okay, so before I have to do this, the limit, I need the limit of float value. So limit of the input variable t, okay? So for example, in this case, it should be a to b, a and b. However, my t should be first lim plus lim1 minus lim0 divided by n times I, right? And then for each t value, I have to put, for example, I have to make define my points. PTS equals to make a plotter x, y, n plus 1. Okay. And for each point, I have to define as plotter xy type, where xy, x and y here. But then I have to define my x and y and z coordinates here. How do I define my x, y, z coordinates? I have to plug in my t value inside of a function already defined to call the function graph. So that function is named f. So I have to take a c equals to f of t. Well, t is actually the input value, but it has to put inside of the array. Okay. You see, going back to our function graph 1 to 3, this f is my function, or maybe if it's confusing, I can make it to c. Okay, so c is my name of function, just like I did in the blackboard. And then the value should be, let's say, I have to use a different name, so let's say call it d. Okay, so I put in t inside of array and then plug that array inside of c to get the value of 3 numbers. And d, I store that in d. So d is an array of floats. So x is the first value of this array, and y is the second value, and z is the third value of this array. And when I plot anything, I have to use the same the same correspondence of vectors here. We have x coordinate as minus x divided by mass square root of 2 plus y, right? And then y is minus x square root of 2 plus z, and that's it. So we defined n plus 1 values of points, and after that we have so line is plotter new line from points, and we have to add this line. Did I use line before? Okay, so I have to get rid of this colon. Okay, so this is the adding line. So after adding line, that's it. That's everything we need. So we have to save it to a file. So let's go back to this line. Just copy paste. P. Okay. That's it, and let's go back to main. So if we define my function as 2-to-1 file, I can use 2-to-1, but I'm not going to use this function. I'm going to define a new function called c. And this function is defined to be, let's say x is now the input array, but only contains one element in this array. So I will always access that value by t0. And let's see, to make it interesting, try to make it spiral. So I'm going to use the cosine and sine function. So let's say first value, x coordinate is cosine t, and the second value is sine t. And the last value is just t. You have to wait a little bit before it automatically imports this math package. But however, let's see. I will graph this function, which is 1, 2, 3. So what's my range? I will range my t from 0 to pi. Sorry, it's messed up. Pi, right? 2 times messed up pi. Wait until it auto completes here. If it's not, let's make it here. Okay. What's the problem here? Math. Import math package. Maybe we should wait a little bit more in order to compile it. Or, okay, I didn't do anything wrong here, so just importing math here. All right. So instead of using graph 2 to 1, I use graph 1 to 2. These are separate files, so let me make it concise here. So graph 2 to 1 is the function we previously defined. I just defined graph 1 to 3. So I'm going to use 1 to 3 here. Let's see what's going on here. Main.go. And the result will be the file test.png again. So here's our picture, spiral picture. So let's see, I used cosine t, comma sine t, comma t as my function, formula of function. So when t runs from 0 to 2 pi, so when t runs from 0 to 2 pi, we have a circle running from the 1, 0 to one circle spiral once, and then z coordinate is moving, increasing, so we have a point moving upward. So we have x, y, and z. So if you're looking directly down onto the xy plane, you only see the point moving around the circle. But in 3 dimension, it actually looks like it's, does it make sense? So like this. So it spiral this, sorry, maybe we should start from here and ends at the same point here. It rounds the z-axis once, right? That's what you are looking at this screen. There's my cursor. Okay, so we have picture of spiral figure. Okay. Is everything good? So let me finish off with asking 2 questions. Well, actually, this is the point where you have to ask questions. But let me start from my question again. So why do we care about the graph? Why do we need graph of a function? What do you think? Why do you need graph? what kind of information did you get from graph of single variable function?
We can see the change by using the slope.
By using the slope, you can see the rate of change, right? Yeah, good one. So, rate of change. And what else? Shape.
So we can find the features of this function.
Uh-huh.
Examples 대칭이요.
한글로 뭐 말해야 돼요, 용어는?
그러니까 그래프를 그림으로써 이 함수에 대한 대칭이나 이러한 여러 가지
대칭.
이러한 특성들을
네.
확인할 수 있다.
Yes, that's good answer. So he said we can find out some features of the graph, for example, symmetry, and etc. I'd like to talk about more on etc. So what kind of features that you can get from looking at the graph of function other than symmetry? So recall what you learned from high school calculus. Maximum, minimum. Yes, that's a good, really good one. Yes, maximum, minimum, and critical points. And what do you call when function looks like this? Like what do you call this function is at x0? Okay, yeah, it's it looks like local minimum, but or global minimum. But what if continuity? Yes. And maybe more. If you know how graph looks like, you can find out. So naturally follows from continuity concepts. When you move your point to some point, then you can find out the end value of function, which is called the domain is also good. We are moving point from inside of domain to the boundary of domain. Then what do you get for the output of the function? The range, and we call it usually the limit of a function, right? So limit. So that's nice aspects or nice features of the function that we can get from the graph. Do we have another? So how do you say the difference between this kind of function and these kind of function? What's the difference between these two types of graphs? Curve is change. 한글로 해도 돼요. 변곡점. Inflection point. It's called inflection point. Yeah, it looks like inflection point. But can you define whether this is an inflection point or not? I think inflection point is defined when you can take a second derivative, right? But here, you don't even take the first derivative because it's not differentiable. So by looking at this graph, it's a pointy graph. You see that this function, the white one, is not differentiable at this point, right? So what's the thing that should be here? You can check the differentiable or not. So it's called differentiability of a function. I think it's fair enough thing that we have to think about. We will going to talk about these things. We have done these things for single variable function the last semester. Now we are ready to talk about these things for multivariable function. So whenever we have to talk about this concept, we will use the graph of a function that we already made. All right, so that's it for today, and we will have class on Friday. If you have any questions, please ask after the class. So thank you for participate, and I'd like to see more students to came into the classroom and discuss more.